In this lesson, we're going to be looking at the agents of erosion, or the things that actually cause erosion to occur. Gravity is essential, so just a reminder that weathering, remember we talked about chemical weathering and physical weathering or mechanical weathering. Those broke down the rock into smaller pieces. Erosion moves the rock. So weathering breaks it down, erosion moves it, and then deposition is when it stops moving. This is an essential component in making sedimentary rock, right? Sedimentary rocks are rocks that are made up of little bits and pieces of other rocks. In order for those to form, we have to break down the existing rock, we have to move it somewhere, and then we have to have it stop moving and be deposited. A lot of what's going on here is related to gravity, and I'll explain why that is. So, take those little bits and pieces, we move it somewhere else during the process of erosion. So there's lots of different agents of erosion, and we're going to talk about all of these. The running water, glaciers, wind, ocean currents, and waves. So you don't have to worry about writing in your notes just yet, because we're going to go through each one of these individually. Gravity. Gravity is going to move things from areas of higher elevation to areas of lower elevation. That's its primary thing, because stuff moves downhill. Gravity is going to try to pull everything to the lowest area. So rivers and streams and things like that, they start usually up higher in the mountains. Even where it looks relatively flat, there is a grade, or there's a slope in that area. So you think of the Mississippi River and how big it is, and I don't know how many of you have actually seen it, but you know the bridges that go across it are pretty wide. And it looks like it's really flat in those areas, but there really is a slope that's going downhill towards the Gulf of Mexico, and that's why the Mississippi River flows from up in the northern plains all the way down through the center part of the United States and is deposited down into the Gulf of Mexico. Once it stops moving, that's where we get deposition, and that's what some of these pictures are. So this is showing deposition of sand in the stream beds. You'll see deposition. We'll talk about how rivers move and why they move the way that they move, and why sand and smaller particles are deposited in certain curves. Sand on the beach is deposited by the waves. So once again, gravity is going to pull things downhill. The strongest area of our gravitational pull of our planet is at the core. So as you go away from the core, the amount of gravity, the pull of gravity, is going to get smaller. So the areas that are lower down in elevation are still closer to the core, so they have a stronger pull of gravity, and that's why stuff rolls downhill. So gravity is one. Water is our next one. Water is one of the strongest forces of erosion that we have, simply because we've got so much of it. We've got our planet, is, 2/3 water, 70% water, and so we've got a lot of it around. Water picks up particles, and those particles tumble along as it goes, and that's what carves away at the rocks. So in this particular picture on the left-hand side, what you'll see is what we call a V-shaped valley. A V-shaped valley. See, it looks like a V as you come down. And that's because the river is cutting down at the bottom. And then you get gravity that's acting here. So the water is cutting away here. As the stream moves, we'll talk about how streams carry sediments and stuff like that. But as the particles are carried in there, they tumble along and they rub up against the canyon walls or the bottom of the stream bed, and they're going to keep cutting away and cutting away. And then as time goes on and the river's further down, now up here, now you've got gravity pulling it down, you've got rain, and you've got other stuff going on. But in this particular valley, this is the primary agent of erosion, the thing that's moving away the soil and rock. You can see here, this is a much younger stream. Okay, this one's really old. This has been here for a while. In order for this to happen, that stream's been there a long time. This one, not so long. You can see, look at the size of the banks. Okay, it hasn't been there very long. You can see where the general area, the flat area would be, where it would have started out at, where it started cutting. So it hasn't cut down very far. In this one, this was the level where the river started and cut downward from there. When it's really early on, we can get what's called rill erosion. And rill erosion happens because usually it happens during rainstorms when there's no real set stream area. Okay, there's no set stream bed, really hasn't started its own stream yet. You can see that one of these rills probably will end up turning into a drainage, even if it's just a dry drainage. But rill erosion, I always think it looks like somebody took their fingers and just scraped it along the ground. You see all these little, these are called rills, all these little indentions in the ground here, and that's where the water was scooting down. Okay, so it rains a lot, and the water just moves across the surface of the land in a sheet action. So it just covers the whole land surface instead of getting collected into some stream areas. Now these areas here are going to end up developing into what's called gully erosion, which is down here. So these, if they're left unchecked, they will turn into gullies, and then you will have a dry, probably area where like what we have, where you have like a dry wash, except for when it rains. But this is gully erosion. This is where those rills got bigger and bigger, and then you start to have failure of the land. Just to give you an idea, this is a truck back here in the back, if you can't see it. This is the fence line. So this is a pretty deep gully. It had some pretty extensive rain in that area. So our streams move, right? Their erosion is moving the sediment, right? All those broken down bits and pieces. And when the water slows down, it's going to start dropping sediments out, because the thing that allows the water to carry the sediment, those little broken up bits and pieces of rock, is the speed of the water. And so as the water slows down, it can't carry as much, and that's where you start to have sediment that falls out. So in this top picture here, all these lighter blue areas are areas where the water isn't as deep because sediment has been dropped down. So what you've got here is the mouth of a river coming down into the ocean, and you get sandbars, and you get little channel islands and stuff like that that will start to develop. But all this land area in here is the result of sediment being carried down through the river and then being dropped. And in this bottom picture down here, this one here is the Mississippi River, okay, as it comes down into the Gulf of Mexico. And all this in here, this whole area, this little spit of land that's there, is all sediment that was carried down from the whole length of the river, which is kind of cool when you think about it. So we're moving land from like Minnesota and the Plain States and all of that, we're moving it down into the Gulf of Mexico and making new land. And that's what this is down here. That new land is called a delta. So as the water drops that sediment into the ocean there, and it starts to build up, it becomes what's called a delta. Still looking at water. So we've had gravity, right? And we've got water. So we've had rivers and streams that move our sediment, and we also have waves is another way that water moves our sediment. So the ocean is constantly moving around, but as you get closer to shore, it most directly impacts the land. And that's where you're going to have it's both an agent of weathering, right? Because the waves are crashing up against the shoreline, and they carry those little bits and pieces of sediment that are going to eat away, and they're going to, with friction, they're going to rub up against the coastline, and that's going to cause the sediment to break down and to cause the rock layers to break down. So you can get cliffs, like here, and this is in Northern California. You can get arches, like this one over here. This is in Cabo San Lucas. And when this breaks off, this will be called a sea stack. And then eventually, you can see how this is already starting to get eaten away. This is limestone in here. You can tell just by the color of it. But you can see there's a big crack going up here. You can see how it's getting eaten away here. You can also see how it's narrower at the base, and then it kind of poofs out a little bit. Same thing down here, because the water is eating away. At this layer here, the waves crash up against it and it eats away. So this will fall first, and then you'll be left with a sea stack. And then eventually the sea stack will fall, and you'll be left with a platform, a sea platform, and then eventually that'll get eroded away as well. So that's how we get these fancy stuff, these really pretty landscapes along the edge of continents. So The other thing that we get are depositional features. So those were erosional features in this one. The cliffs and the sea stacks and the arches and stuff, these are because of erosion. These are because that sediment is moving and it's eating away at it and it's moving away from this area. So those are erosional features. These are depositional features. So when we get our beaches, and this one's called a sandbar. You can also get ones that are called spits. You can get areas where they form like a little barrier across the mouth of a bay. And all of this is because the waves slowed down in this area and dropped the sand. Now, sometimes our beaches, we get like a big hurricane or something like that, and it moves. The hurricane will move all that sand, and it'll move it away from the beach. And in the United States, in particular, we do beach restoration, especially in the southeast coast. There's a lot of expensive property in those areas. If you think about Hurricane Sandy, that happened a few years ago, up in New Jersey. They came back in and they restored those beaches. They went out with these giant ships that kind of like oil tanker sized ships, really, really big ships. And they basically had like a big vacuum hose, and they would suck sand up off of the ocean floor, off the continental shelf, and then they bring it out onto the beaches, and they would then put all the sand onto the beaches. It was called dredging, when they pull up all that sand, so they could restore the beaches and make them bigger, because nature's doing nature's thing, but we built houses and things like that, and so people place value on that, and so they want to make sure that we don't lose that value. In Dubai, I haven't heard so much about it in the news lately, but a few years ago, I don't know if you remember, they made islands off the coast of Dubai. Excuse me. And they made like a palm tree, and they made one that was shaped like the world, and they went in and they dredged sand, and they actually built islands using this restoration type method, and they built, like, people could buy, they could buy a continent in the world one, they could buy, space on the palm frond, and they built houses and all the hotels and all sorts of crazy things. But if you're ever bored and you want to Google, look for the islands off the coast of Dubai. They're kind of cool. All right, so we had gravity, we had water, and now we have glaciers. So we take the water, we froze it, okay, and now we've got glaciers. So glaciers happen in areas where it stays cold all the time. The snow builds up on the snow fields, and as it does, the snow gets compressed down over time, and it turns into ice, and it forces out the air bubbles and stuff like that, and it makes a really solid chunks of ice that are heavy. And a glacier is basically like a giant flowing river of ice. So it's going to, once again, it's going to move downhill with gravity, right? None of these things happen exclusive to one another. So the gravity is going to pull that big chunk of ice downhill, and as it does, you need to imagine many, many tons of ice that has dirt and rocks and all that kind of stuff underneath the bottom of the glacier. Is really dirty. It's not that pretty white snowfield that you see on the top. It's this big jumble of stuff that's on the bottom, and it can carry some really big boulders and stuff, and as it moves downhill, it's going to scrape and it's going to grind and it's going to flatten out, or it's going to cause these valleys as the glacier moves downhill. And then when the glacier recedes, it's going to drop behind some stuff that we'll talk in a little bit about. It's called a moraine. It's the chunks of rock and things that it leaves behind when the glacier melts. But as it's moving down, it's going to scrape and scrape and scrape. And so because the glacier is wide and big, it makes U-shaped valleys. So if we look over on this picture, okay, this mountain here is the other side of this one over here. So it's a big U-shaped valley. That's the size of the chunk of ice that went through it. This is in, I think this one's in Montana. But this is the big U-shaped valley. So our streams, right? The thing that's moving all the sediment is really narrow down at the bottom, so it made those V-shaped valleys. It made those nice tight valleys, right? But our glaciers are big chunks of ice, so it's making the big valley. Here's another one. This one is at Glacier National Park, which if you've never been and you want to see a real glacier, You need to go before the year 2030 because that's when they're predicting all the glaciers will be melted and gone. It's a super neat place to go. Even once the glaciers are gone, it'll still be cool, but it's neat with glaciers. So, erosion scrapes it all out, right? But glaciers also deposit sediment on our landscapes that then leave different features behind. So as that glacier kind of scrapes and moves everything, all that stuff that it scrapes up gets caught up into it. And then as they melt, it kind of leaves it all behind. When streams leave sediment behind, they fall out because of gravity. And so it usually is really nicely ordered. You got the bigger stuff on the bottom because it was heavier and it fell out first, and then you got the smaller stuff. But glaciers, when they melt, just drop everything. So you get this weird jumble of stuff all over the place. And they're called moraines. And we have moraines that are on the side of the glacier, which are called lateral moraines. And that's where the edges of the glacier on the sides started to melt and dropped all the stuff. And then you have the terminal moraine, which is what was at the end of the glacier. And then it's like a big ridgeline of stuff that was at the end. And that it drops all sorts of junk out of the top of that. So we've got lots of our, the northern part and actually the Midwest. One of the reasons we have the soils that we do there is because of the last ice age, when there were continental glaciers that reached all the way down into the upper Midwest. And as they receded, they left all this fine sediment behind that was really good for agriculture and really deep soils. In areas like Minnesota, the land of 10,000 lakes, all those lakes are a result of the glacier. So as the glacier receded, or as the glacier went through, it kind of scooped out all these little holes in there, and then as it melted, all those little holes filled in with water, and that's where most of our lakes came from, up like in Minnesota and those areas, is from the last ice age and those continental glaciers. It's also the reason why you'll see random giant boulders just out in the middle of nowhere, up in the upper Midwest. They all just because when the glacier melted, it left all that stuff behind. All right, so we had gravity, we had water, we had our flowing streams, we had our wind, or our waves, excuse me, and we had our glaciers, and now we've got wind erosion. So wind erosion only moves fine particles, the little small stuff, because wind is not as strong of a force as water and ice is. So it's going to be a problem in our coastal areas along beaches. It's also a problem in our plains areas where there's not much vegetation to break up the wind. So in our Great Plains, when in the 1930s, in the 1920s, when we had the Dust Bowl, okay, wind erosion was what caused all of that. Bad agricultural practices, and then wind. And when the wind blew in the Dust Bowl, it actually blew those dust clouds all the way out into the Atlantic. It made it so that in the middle of the day it was dark in New York City because of the dust that came from the Great Plains. So it's only going to pick up the little small stuff because anything larger is going to be too heavy. So we can get erosional features like this. This is a rock that the wind blew going up this way and eroded it and move that stuff. We also get depositional features like our sand dunes. So our last kind of erosion that we're going to talk about is by living creatures. So we had our gravity, we had our different kinds of water, we had ice, and we had wind, and we've got living things. So critters, as they burrow down, moles and stuff like that, as they burrow down in the ground, they're causing erosion. They're moving the dirt, right? When they make their holes. Ants, termites, anything that burrows in the ground is going to move dirt around. Earthworms, okay? Any critter that's moving dirt around is actually causing erosion. So we had gravity, we had our different kinds of water, moving water, we had ice, right, in our glaciers, we had wind, and we have living things. One last check for understanding quiz in Canvas. The same rules as before. You have to get 100% in order to move on, and you have as many chances as you would like.